Welcome to this note, Blockchain Technology Explained. I am so incredibly thrilled you're here today. We're literally standing at the edge of a massive shift in how the world operates. It's what we call the digital ownership revolution. Now, this isn't just about moving digital coins around. It's about fundamentally restructuring the global economy. By the time we finish up today, you're going to see exactly how this technology offers incredible real-world impact, and more importantly, how it unlocks unprecedented career and wealth potential for those who truly understand it.
I really want you to think about this for a second. What if the internet had a built-in trust system? I mean, for decades, our digital lives have relied entirely on centralized systems. Banks, tech giants, governments. They all act as these middlemen to verify our identities, hold our money, and process our data. But as we've seen time and time again, centralized points of failure lead to massive data breaches, painfully slow transactions, and blocked access. By shifting from central authorities to cryptography, we are laying the groundwork for the absolute future of money, applications, and your digital identity.
You see, we're moving from an internet of information to an internet of value. This is the digital ownership revolution. It's the ability to securely own, transfer, and program value literally anywhere in the world instantly without asking anyone for permission. And pay close attention, because later you'll understand how companies build billion-dollar blockchain systems to do exactly this.
Here's our roadmap for this note. 1. The digital trust system. 2. How blockchain actually works. 3. Real-world power and applications. 4. Hidden risks and mistakes. 5. Your career and money. And 6. Building the future economy. I'm going to be your digital mentor today, guiding you through every single step.
Section 1. The digital trust system, the foundation of decentralization. Okay, let's dive into this. Before we get into the complex cryptography or all the advanced applications, we really need to understand the basic concept of what we're actually dealing with here and why it fundamentally exists in the first place.
Well, at its absolute simplest, a blockchain is just a ledger. Think of it kind of like a shared digital notebook. Imagine a Google Doc that's shared with thousands of people. Every time a new transaction or note is written, everyone's document updates simultaneously. But here's the critical difference. In this specific digital notebook, once a line is written, it is permanently locked. No single person, not even the creator, can go back and erase or alter that line. It's entirely tamper-proof and maintained by a decentralized network rather than just sitting on a single company's server.
Under centralized trust, you have to rely on a single entity, like a bank, to ensure nobody spends the same dollar twice. But back in 2008, an anonymous figure named Satoshi Nakamoto published the Bitcoin white paper, proposing a totally new model. Nakamoto introduced decentralized trust using a peer-to-peer cryptographic network. So instead of a bank verifying your balance, a global network of computers mathematically proves it. This perfectly solves what's known as the double spending problem, making true electronic cash possible without a financial institution.
Section 2. How blockchain actually works. The core mechanics. Now imagine we are building this step by step. We're going to shift into engineering mode for a minute. How does a transaction actually go from a tap on your phone to a permanent record on a massive global network?
Here is the exact flow. First, a user initiates a transaction from their digital wallet using a private key. This transaction basically goes into a waiting area called a mempool. Step 2, independent computers on the network, which we call nodes, grab this transaction and verify that it's legitimate, checking that you actually have the funds to spend. Step 3, valid transactions are bundled together to form a block. Step 4, the network uses a consensus mechanism to agree that this specific block is the single version of the truth. Finally, Step 5, the block is permanently added to the chain and everyone's ledger updates across the globe.
And this brilliantly illustrates the real magic of the system, the cryptographic hash. A hash is a mathematical function that takes all the data in a block and turns it into a unique, fixed-length string of characters, basically a digital fingerprint. Every new block contains the hash of the block that came right before it. Because they're chained together this way, if an attacker tries to change even one tiny detail in an old transaction, well, it instantly changes the hash of that block, which entirely breaks the link to the next block, triggering an alarm across the whole network.
But how do those computers actually agree on which block to add? They use a consensus mechanism. The two main ones you really need to know are proof of work and proof of stake. Proof of work, which is used by Bitcoin, requires miners to use massive computing power and energy to solve a complex puzzle to earn the right to add a block. It's highly secure, but yes, very energy intensive. Proof of stake, used by Ethereum, replaces miners with validators. Instead of burning energy, validators lock up or stake their own capital as collateral to secure the network. Section 3. Real-world power and applications. Beyond cryptocurrency. So, we have this immutable, secure distributed ledger, but what does it actually do? It's time to look beyond just buying and selling cryptocurrency, because this technology powers solutions for some of the world's largest industries today.
Take the supply chain industry, for example. Global giants like IBM and Maersk are actively using blockchain right now to track the movement of goods from manufacturers directly to store shelves in real time, which completely eliminates fraud. In healthcare, it's being used to create interoperable, highly secure electronic health records, where the patients actually control their own data. And in public administration, blockchain offers the framework for truly tamper-proof voting systems. The core benefit is always exactly the same: absolute trust and transparency. Building on that, we have the advanced layer. Smart contracts are perhaps the most powerful piece here. These are self-executing contracts where the terms are written directly into code. When conditions are met, they execute automatically. No lawyers required at all. Then we have NFTs, which represent verifiable digital ownership of unique assets. There's DeFi, or decentralized finance, which allows people to lend, borrow, and trade globally without ever touching a traditional bank. And finally, digital identity systems, which will soon allow you to prove who you are online without handing your data over to giant tech corporations.
Section 4. Hidden risks and mistakes. Security is critical. So, the crucial point is, with all this incredible power comes profound responsibility. Because there is no central authority, there's no customer service hotline to call if things go wrong. Your security is absolutely critical here.
You absolutely must be aware of these pitfalls. In the Web3 world, you are your own bank. If you lose your private keys, the passwords to your crypto wallet, your assets are gone forever. There is no forgot password button, period. Furthermore, because smart contracts are just code, they can have bugs leading to massive financial exploits. The space is also pretty rife with scam tokens, fake platforms, and highly sophisticated phishing attacks designed to steal your digital identity. You just have to do your own research, remain vigilant, and completely prioritize your own digital security.
Section 5. Your career and money. Participating in the Web3 economy. Let's shift our perspective for a minute. We've covered the tech and we've covered the risks. Now let's talk about you. How does understanding all of this translate into actual earning potential? Well, the Web3 economy is creating a massive wave of wealth generation and huge career opportunities.
Let's move to and see how this builds. There is a massive global shortage of blockchain developers and smart contract engineers right now. These are roles that frequently offer high compensation and the ability to work entirely remotely from anywhere in the world. But you don't just have to be a coder. Web3 freelancers, community managers, crypto analysts, and DeFi builders are in extremely high demand too. If you have an entrepreneurial spirit, being here right now is the equivalent of the early days of the internet for startup founders.
Section 6. Building the future economy. The roadmap ahead. As we look at everything we've mapped out today, we can clearly see the trajectory. This isn't a passing trend, guys. It is the fundamental infrastructure for the next iteration of the internet, often called Web3. The trends defining the next decade are just extraordinary. We're going to see deep integration between artificial intelligence and blockchain. As AI generates more and more data and content, blockchain will serve as the undisputed trust layer to verify what is real and what is actually human. We're heading towards global tokenized economies, where everything from real estate to intellectual property is traded as digital tokens. We'll even see machine economies, where automated devices use blockchain to transact with each other totally seamlessly.
Now, what's really interesting about this slide is how it summarizes everything we've learned: security, trust, transparency, and immutability. These 4 pillars solve a famous computer science puzzle called the Byzantine general's problem. Basically, how do independent parties agree on a single truth when some of them might be malicious or just flat out lying? Blockchain solves this so gracefully. By combining cryptography with decentralized consensus, it beautifully aligns the economic incentives of the entire network to remain honest.
I want you to really internalize this reality. The concepts we discussed today, hashing, consensus, decentralization, they might feel complex at first, but they are highly learnable. You now have the foundational mental models. You can learn this. You can build incredible applications with it. You can earn a tremendous living with it. You are now equipped and ready to actively participate in the future economy, rather than just watching it happen from the sidelines.
Which brings us to our final thought for the day. The infrastructure has been laid. The trust layer of the internet is operational, it's decentralized, and it's waiting for innovation. The tools are sitting right in front of you. So my question to you is, what will you build on it?
Take this knowledge, dive deeper, and start building. Thank you so much for joining me for this note.